Welcome. Thanks for getting up on the second day of the conference. So I teach in data science at Case Western Reserve University. And the course I teach is called Cognition and Computation in the Department of Cognitive Science. And last year, when I taught it, at the very beginning of the class, I introduced the students to GPT-2, and they were blown away. And this year, when I taught it, I introduced them to GPT-3, and they were blown away. And then ChatGPT, and the whole world was blown away. Now, the way these things work has nothing to do with whether the model, a large language model, understands language. It doesn't. Whether it lies or confabulates, of course it does. It's trained on the internet, so garbage in, garbage out. We're not talking about any of that. What we're talking about is this thing gets trained with 179 billion parameters on more data than all the linguists in history could look at in all of their lives. It's fabulous, unimaginable amounts of data, right? And it succeeds not when it tells you the truth or is reliable. It succeeds when it mimics form-meaning communicative expressions. And if it doesn't do that really well, then we all think it's a disaster, but we all think it's really good. It captured the whole world. So you give it data, it vectorizes, which means it creates vectors for words and uses a cosine analysis of how close they are. I've used this before to try to do frame embeddings because I thought, well, if we find two frames that are overlapping in a clause, maybe that's a frame blend. Not always. So you can go to my website. There's a talk on frame embeddings from a couple of years ago. So the con artist can be full of nonsense, but still a master of language. So if these things are very good at imitating patterns, can you ask it to give you examples of constructions? Can you ask it to nominate a new frame for FrameNet, right? Can you use it as a linguist to help you find and check things in virtue of its infinite training in 43 languages and everything in the world? So here's the history. I said to Thiago, head of FrameNet Brazil and Global FrameNet, hey, let's work on this project. And he said, great. And a few weeks later, he said, and let's bring in Arthur, because I said, oh yeah, Arthur's got to be it. So that's what you showed up for. But now we've had an upgrade. Thomas Hoffman, one of the editors of the Handbook of Construction Grammar, gave a talk. I found it online. And he was talking about using large language models to help the construction grammarian. And I said, Thomas, you got to join us. So he did. So we started off with copilots for Frame Semanticist, but now after the upgrade, we have copilots for linguists, AI constructions and frames. That's our project. Now, what are we doing with this thing? We use these AI large language model chatbots. We have used both OpenAI's closed chatbot and an open source chatbot, and we ran experiments on these. Can they help the linguist? So we're not asking whether they understand language, put that out of your mind. What we're asking is what can they do for linguists? How can they be exploited in virtue of all this training they've had? So it's not a talk about whether, I'm sorry to repeat this, but I feel the world is misguided in trying to talk about large language models. They don't understand language, they lie, and they agree with their human users. So we all know all of that. We'll give you good examples of that. Instead, what we do is we do exploratory prompting of these things to figure out how they could help a linguist, or if they could. We get the AI response. The whole trick is prompt engineering. because these things generate the next word. So your prompt is the set of words that it has to follow. And you can write a prompt and get a disaster, or you can write a prompt of the same number of words and get a great success. Prompt engineering is the big deal. So then we create prompting algorithms so that the human being doesn't have to do all the work. And we iterate. We get automated prompt generation so that the linguist doesn't have to be thinking up all the appropriate prompts. You can have an idea, stick it into the algorithm. It will prompt the chatty AI large language model, and off you go. Bob's your uncle. Okay. Our methodology was that we took two existing models, and in fact, we trained one on a 48 gigabyte GPU at Case Western Reserve University, high performance computing. So gratitude to my peeps at Case Western Reserve University for making available to me all this awesome hardware. And we will talk about, we performed qualitative explorations, quantitative explorations, and we tried to investigate what kind of risks there are for the linguist, and you will see all that. The kinds of constructions that we prompt for, we ask hi. Things like, there is an unverb construction. This one I think came from Thomas Hoffman. Great verbs such as unbutton or untie, right? So please give 10 more examples of the construction. And if you ask it something that blunt, well, it will give you a bunch of them, but the important thing to see is it's going to not cogitate, but it's going to have in its history what you asked. And the examples you give are sort of reversal, unbutton, untie, right? And in fact, the meaning of the construction is reversal. So it will follow you. Unravel, to reverse an unraveling action, right? Okay, you don't like this. It's very important. This is a co-pilot for linguists. The co-pilot should never be allowed into the pilot's seat. The linguist will not be fooled by this thing, but it's going to get it wrong. And a lot of the time it's going to get it wrong is because you gave it a prompt that invited it to get it wrong. But then you can see it. You say, well, I should have written a better prompt. Okay, there we go. And now we're going to talk about the main project, which was, we want to expand FrameNet, right? We want more frames in FrameNet, more XML representations. This is a real project on the ground. Can we use it to help us expand and improve FrameNet? Arthur.
Thank you. So we know that FrameNet has several pieces of information. So we can think of names, frame names, frame definitions, LLMs, and all of that. One of the things that we decided to work on first is on testing those models to see how they would behave when we ask for new LLMs and new frames. We didn't work with the structure, like the network structure that much, just because it's in a textual environment, and sometimes explaining all of those relations can be complex. So we focus on what information do we want to give to the model before asking things. And for that, we have this algorithm that will automatically generate the prompts that we want to test. Basically, the way it starts is we have a collection of templates, and then we would feed that information to the templates. So first, we would say, well, there is a frame with this name and this definition. Optionally, we can include all of its FEs. Sometimes we can include, if we want, their definitions and maybe even the unexpressed FEs. And then we would go in separate ways, depending on the prompt type we want. So for example, if we want the model to create new LLMs, we would have something like propose 10 new LLMs for this frame that we just presented. But if we want a new frame, then we go to this different branch. And then we can find a type of relation in the noun. So for example, if we think about inheritance, we can find existing child frame of the first and do the same thing. So we would have two frames and specify their relation with their complete data, and then ask for new attributes, or and provide example values of this frame, and say, hey, can you provide a new frame that relates to this two? So we can do that for different types of relations. For example, perspective, we can ask for a different perspective given two frames. Thiago is going to explain how we did it for new frames, and I'm just going to go over how we prompt for new lexical units. Obviously, different frames have different characteristics. So we have to select first, in our experiment, what are the variables that we think might be relevant to analyze this. So we looked at the frame group types. So we separated frames into different groups based on whether they are entities or attributes or events. We also separate them between their LU counts. Maybe they're all framed with lots of values in FrameNet, and some with just a few. The same thing happens to frame element counts, and that might relate to the event frame type. But we also consider two different languages, here English and Portuguese, to see how well those models behave, because they were trained in lots of languages. We found out that with entities were the frame types that the model was better able to get new LUs. And when we have a lot of LUs, as example, to say, well, we have the animal frames and we have all of those animals. Can you propose new LUs that would fit this frame, for example? We also found out that the more frame elements that the frame has, the harder it is for the model to propose LUs. That might show us that very complex frames with lots of props might be hard for the model to really suggest LUs, and that they perform better for English. So here's I'm just going to go over the table real quick. This just shows the correctness rate of the proposal values that we had to evaluate manually for each of the scenarios. And in parentheses are the rates of those values that the models propose, but that are already existing in other projects expanding FrameNet, such as FrameNet Plus, or in the case of Portuguese, we check FrameNet Brazil's database. So this is just for ChatGPT in English. But if we looked at the other variations, basically what happened is when we checked for Portuguese, the model lost a lot of performance, even though it was technically easier because it was not constrained to not repeat the already existing LUs in English. And also that ChatGPT is consistently better than Open Assistant at suggesting new LUs. And I didn't show all of those tables just because they follow all of the same trends. So basically entities are easier and more LUs are better. And that's how the models end up working. So I'm going to pass to Thiago now. He's going to talk about the frame.
So when prompting for the rest of the structure of frames, so to getting new frame names, new frame definitions, new frame elements, and new LUs for the created frames, the parameters that we analyzed were first the frame root type again, if it was a entity-like frame, attribute-like, event-like, whether the frame was lexical or non-lexical, so the first frame in the prompt, the specificity, if it was a very high-level frame, so the entity frame itself, the attribute frame itself, or a mid-level frame, such as artifact for entity, or transitive action, or intentionally affect for events, for example. The expressiveness of
frame element. So some prompts mention that the core frame element was unexpressed, and then in some we removed this information, and we did that consistently for all the prompts and all the tests to see the differences in the results. The nature of the AI that we use, if it was proprietary or not, and the prompt history. So if we were continuing a previous chat, or if we cleared the history and started from scratch for every new frame proposal. So everything that is seen in yellow made a positive impact in general, right? So this is interesting because one of the great new things about ChatGPT and Open Assistant is that they can continue a conversation. But for most cases, continuing the conversation was bad because those assistants, as we pointed out in the safety instructions, they rely on the chat history. They are designed to do that, right? And so what it means that sometimes they stick to wrong definitions or to frame elements that are not adequate. So when we prompted for entity frames, I'm going to show you some of the results. All of them will be available really soon. So this is a mid-level frame, is the artifact frame. And basically the prompt was, there is a semantic frame for artifact. It's defined as follows. Those are the frame or frame elements. The definition of the frame elements is this one, and the words evoking this frame are those ones, right? So this was automatically generated by the algorithm that Arthur has shown you. And then in the continuation of the same prompt, so the frame for information display inherits artifact. So we provided a daughter frame inheriting the mid-level frame, and then we provide the same information, definitions, core frame elements, definition, words evoking the frame, and we ask both assistants to propose as a table new frames, right? So this is what ChatGPT proposed the musical instrument and the weapon frame, right? And for example, if you look at the weapon frame, it has one frame element, that's the definition, and those are the LUs, and it's almost the same as the already existing weapon frame in Berkeley FrameNet, right? For Open Assistant, it proposed other frames, but I chose tool and vehicle. But you see the AI here builds a different representation for the words on the table to the extent that it lists as frame elements the parts of the word it lists as a frame. So usually tools have handles, blades, and motors, and vehicles have wheels, wings, and engines, but those wouldn't be the elements, right? In a tool frame, FrameNet, or in a vehicle frame on FrameNet. This is a lexical relation. This is a part of relation that somehow is there, right? Given the embeddings. And the same goes, so actually Open Assistant proposes physical artifacts and digital artifacts, but makes consistent mistakes, right? There. For attribute frames, the performance usually is inferior, so we prompted with the gradable attributes frames. And then the same idea here, the difference being the core and express frame elements. And we use the color frame as the child frame for the prompt. And then ChatGPT first proposed those frames with only one core frame element named entity. And the definition of entity was the same. But actually, this definition and this frame element come from the history of the conversation, because this was a follow-up on a question about the entity frame. So it relied on the definitions that we have previously given to them. So this is the big mistake. And then if you continue the conversation and ask, why did you propose only one frame element per frame? And then since I propose only one frame element, because each of the frames I listed describes a specific attribute or property of an entity. And then, for example, in the size frame, the entity is the thing that has a certain size, and the size itself is the core frame element. But on the table, there was only one core frame element, and it was the entity. Right? And then if you continue, but for color, there are two, entity and color, and they say, you are correct. Again, it agrees with you, right? But then it says, in the frames that I propose, it is not necessary to include additional frame elements because each frame describes a specific attribute or property of an entity, and the attribute or property itself serves as the core frame element. So it returns to the same frame that it had done before, right? So for the attribute frames, discussing with the chatty AI LLMs rarely improved the performance, but changing the prompt did. So instead of continuing the conversation, we prompt again the same thing, right? But first, we clear the history, and then we remove the information about core and expressed, right? And then you get more similar frames, such as the temperature frame, again, with entity, degree, and temperature, which is to some extent similar to temperature, entity, degree, and attribute in the Berkeley FrameNet temperature frame. For events, we prompt with transitive action. Those were the best results. And first, there was this proposal from ChatGPT, cooking and healing with agent and patient. And you see the agent is the entity preparing the food, and the patient is the food being prepared. And then in the continuation, we said that some of those frames, such as healing, would involve a medication frame element, and also frame elements in FrameNet are more specific. So instead of agent and patient, you should think of healer, for example. Please correct. And it did correct the name of the frame elements and the definitions, but he kept the frame definition. He kept the LUs, right? Not he, it. Sorry, it's Portuguese bias in my English. So for all types of frames, the systems provide useful output at some level, right? But both systems perform better for entity frames, as it is the case for LUs. And this is mostly due to the fact that the structure of entity frames in FrameNet resembles more ontology level classification. So they have usually 1, 2 tops frame elements, right? And the way they are grouped usually match word embedding. So if you have an animals frame, you would have lots of names for animals. And if you have a word embedding for dog, it's very likely that you're going to have cat and mouse, right? So it's closely related to the kind of underlying representation that those models have. Also, the chat history interferes sensibly with the results. So keep talking with the assistant. It's kind of not the way to go. And every deviation from the pattern in the prompt impacts the performance. So as Mark said, every tiny thing that you change has a huge impact on the performance because it changed the word embeddings or whichever the representation is underlying this systems. We do think it's a way to go. We do think it's interesting and that there are lots of possibilities. But before we all embark on this train, we should mind the gap, right? So we decided to be mean with the AI. Yeah, I did that. I'm proud. And we prompted with English has a construction named inverted order, where the direct object of the verb can be used before the subject to indicate that the action performed by the subject and affecting the object was unintentional. An example of this construction would be the vase Mary broke. Please provide 10 additional examples of such construction and explain the meaning. The car John crashed, the sentence implies that John unintentionally crashed the car. And then you have 10 examples, we just pasted some here, that follow the pattern. So it will agree, right? Okay? So, we do believe that those tools still have much to learn.
Much to learn, you still have.
Right? And actually, we point to some paths towards this direction. But the idea here is that large language models are tools, right? As the sketch engine is a tool, okay? But the thing is, we have to recognize their limitations. So they are brittle, and their unreliability, and the fabrication of seemingly scientific nonsense as the inverted order construction in English. So you can find all those examples and more in a book that is about to come out in the Cambridge LLM series. And the final manuscript was turned in on Friday before coming here. So by the end of the year, it's going to be available and as open access for 1 week. Okay, so thank you.